Today I am going to tell about particle in a one-dimensional potential well. So let us consider a particle of mass m moving inside a potential box. So with dimensions a or with a distance a. So separated by the box with a distance a. So here let us take the Schrodinger's wave equation d square psi by dx square plus 2m by h square e minus b into psi equals to 0. So this is Schrodinger's wave equation. So according to the boundary condition, inside the box the potential will be equals to 0. So that d square psi by dx square plus 2m by h square e psi equals to 0. Therefore, d square psi by dx square plus k square psi equals to 0. So that where k square equals to 2m e by h square, where k square equals to 2m e by h square. Okay. So here now applying boundary conditions. So what is the first condition? V of x equal to 0. V of x equal to 0 for x equals to 0. So V of x equal to 0. Then x equal to 0. So what is the solution of the boundary condition? Equation 3. Psi of x equals to a sin kx plus b cos kx. Psi of x equals to a sin kx plus b cos kx. So what is the first boundary condition? B of x equal to 0 for x equal to 0. So psi of x equal to 0, a sin 0. So sin 0, 0. So plus cos 0, 1. So that b equals to 0. So now applying b 0, then find a sin kx equals to 0. So what is the second boundary condition? Psi of x equal to 0 for x equals to a. So that a sin ka equals to 0. So ka equals to n phi. K equals to n phi. So k equals to n phi by a. Okay. So k square equals to n square phi square by a square. So this is the equation 5. So comparing equations 4 and 5. Therefore 2m e by h square equals to n square phi square by a square. Okay. So e equals to n square phi square h square by 2m a square. So since h equals to h by 2 pi. So h square equals to h square by 4 pi square. Okay. So n square phi square h square by 4 pi square divided by 2m a square. So phi square gets cancelled. Therefore e equals to n square h square by 8m a square. This equation represents energy of the particle. So if n equals to 1, E1 equals to h square by 8m a square. If n equals to 2, E2 equals to 2 square h square by 8m a square. Okay. So if n equals to 3, E3 equals to 3 square h square by 8m a square. Means 9 into E1. 9 into E1. So why? Because 3 square 9 h square by 8m a square value E1. So E3 equals to 9 E1. 9 E1. So E3 equals to 9 E1. So like this, by using potential box we can calculate energy of the particle, and what is the eigenfunction? A sin k equals to 0. So therefore the eigenfunction sin of x equals to a sin n phi by a into x. So this is called eigenfunction. Eigenfunction. Okay. So here, what is the eigenvalue? So you can calculate the probability density modulus sin square dx equals to 1. So you can calculate probability density. Okay. So how you can calculate probability density? So integral modulus psi square dx equals to 1. So modulus psi square a square sin square n phi by ax into n phi by a dx equals to 1. So a square. So multiply and divide with 2. So a square by 2 into 2 sin square n phi by a into dx equals to 1. So 2 sin square theta. So 1 minus cos 2 theta. So a square by 2 into what are the limits? 0 to a. So 0 to a. So 1 minus cos 2 n phi by a into dx equals to 1. So 1. So now we apply limits. A square a by 2 equals to 1. So a square equals to 2 by a. A equals to root 2 by a. So that what is the eigenfunction? Sin of x equals to root 2 by a into sin n phi by a into x. So this is called wave function. So what is the energy of the particle? M square by 8 ma square. So what is the eigenfunction? Sin of x into a sin of x equals to a sin n phi by a into x. So what is the eigenfunction? Eigenvalue root 2 by 2. So that what is the graph? So here sin. Okay. So probability density and function sin of x, sin of 1 with sin of x, sin 2 of x. So here. So in quantum mechanics, you can calculate energy of the particle in a one-dimensional potential box and eigenfunction and eigenvalues.